quarter, we should have just finished the linear unit where you graphed data points or may have seen graphs of data points and everything landed in a nice straight line. Unfortunately, when we graph real data, things don't always lie in the same nice straight line, and then we create what are called scatter plots. So this is the beginning section on data statistics and scatter plot creation. And so we're going to start off with a set of data points, independent and dependent variables. The independent variable are the number of hours spent in a mall, and the dependent variable is the dollars that people spend when they're in the mall, the dollar amount. So I've set up a graph where along the x-axis I've labeled the independent variable, hours in mall, and I've numbered them by ones. And along the y-axis over here, I have it labeled dollars spent in $10. So I went by $10 increments, which I don't know that I necessarily would have had to have written that because you can see from the number line how it's labeled. So really it does go, technically it goes by ones, but every interval marker is $10. So for the first data point, it says someone who spent 10 hours in the mall spent $40. The next one, this one's hard to see, but I had to make my graph a little bit bigger. Someone who spent 8 hours in the mall spent $15. It's going to be halfway between 10 and 20. And then I've got someone who spent 9 hours in the mall, spent $24. 3 hours, $20. 1 hour, spent $10. 2 hours was $35. A 5 hour in the mall, spent $50. 6 hours in the mall, spent $70. 8 hours in the mall, spent $25. 2 hours in the mall, spent $100. That sounds like me shopping, especially with my girls. 3 hours in the mall, spent $60. So with this data set, it appears that the numbers are kind of all over. There really isn't a set pattern to these numbers. So I would say in this case, there really is no correlation. Granted, it does seem to make sense that if you spent more time in the mall, that you probably will spend more money. Although you can see there's a person who spent 2 hours in the mall and spent more money than anybody else did the entire time. When the data set doesn't really seem to follow a set pattern, then it's said that there is no correlation. So we might say that this data set has no correlation. That just because you spend a lot of hours in the mall does not guarantee you're going to spend a lot of money. This person who spent 10 hours in the mall only spent $40. So this seems to really have no correlation. So I went through and I cleared all those data points, and I'm going to kind of do just a for instance sort of thing. And let's say that it really did matter that the number of hours that you spent in the mall did increase or have an effect on the amount of money that you spent. Okay, and I'm just kind of just doing some random dots here, not necessarily putting them on all on the same line, because I don't want you to think that it's linear, that it's guaranteed that if you spend 10 hours in the mall that you're going to spend more money because you spent more time there. Now, if these were my data points, these seem to be clustered a little bit closer together, and they seem to be increasing as we go from left to right. Okay, so I'm not going to draw a line on here because you would not normally connect all of the points on a scatter plot. You wouldn't do a line like that. You wouldn't take your pencil and make a line graph out of it and say, oh, well, it looks like this, and these go up, these go down. Scatter plots do not. You do not connect all the points on a scatter plot. Now we can look at this and say, well, it looks as if the amounts appear to be positive. That when you spend more time in the mall, you spend more money. If this were the case, then this set of data would have a positive correlation. Now, from the set that we had, please understand that these points that I have on the graph right now do not correspond to this chart that I have on here. Once I had it on here for this video, it wanted to stay on here. For this set of data, though, this new set that I just completely made up, you can see that the data points seem to be trending in an upward motion, and that they are kind of set around the same data points. If we had a set of data points, and I'm going to do these in a different color. Oh, let's see. Red and green I know sometimes are hard for people to see, especially if you're colorblind. So try to avoid those. Let's say that the data points did this sort of thing. And the amount of time that you spent in the mall, actually you spent less money. So these seem to be going down and trending downward. This would be, the purple would say to be having a negative correlation. There is no real connection, or in this case, the amount of money or the amount of time that you spend in a mall actually decreases the amount of money that you spend. If you spend 10 hours in the mall, maybe you're there because you're playing in the arcade. Maybe you're there because there's a theater in the mall and you went to watch a movie, and then afterwards you just walked around the mall with your friends. 10 hours is an exorbitant amount of time just to walk around. But you might not have spent any money necessarily shopping if all you did was window shopping or whatever the case might be. That would seem to be a strange situation for that. So now let's say that we had this positive correlation. Whoops, I just erased my number line, but that shouldn't be a problem with what we have left to do. Let's say you did have this positive correlation and you wanted to be able to summarize it. In the linear unit, we summarized a lot of things by making an equation for lines, and that equation was the summary for what we were working with. When you make an equation that fits a scatter plot, what you want to try to do is you want to try to fit as many of the points in a line as possible. Now, I obviously can't use a straight edge on my screen right now. So what I'm going to attempt to do, and you guys have seen how good I am at this, there's sarcasm in my voice, is attempt to connect as many points as possible using the straightest line I possibly can. These three right here, these three seem to be pretty close to being on the same line. So this is what I would call a line of best fit. And a line of best fit is a line that catches as many data points as you can possibly get. Seems to be in the middle of the data points, and by that I can say I've got 1, 2, 3, 4 data points that are above the line. This one's slightly below, and then maybe 3 that are below it. So this is kind of going through the middle of the data. Maybe you might say, well, I think a better line would be if I took, let's see, this one, and this one maybe you could say that they lie on the same line. Maybe you want to take those three. If that's what you think is the line of best fit, because that one gives you 2 that are really close to the line, 2 that are really close to the line, and then 1, 2, 3 above it, and then only 2 below it. You're feeling that you're getting a better fit for the data, then go ahead and do that. I'm going to stick with that purple one that I drew. Okay, and from that, what I want to do is get 2 good points that I can concentrate on. So I'm going to concentrate on this one, and I'm going to say this one. And I would call this first point that I circled maybe 5 hours spending, let's say, $36. And this one over here at 7 hours spending $54. Okay, because I used a straight line to model my data points, I want to be able to try to write a linear relationship for it. I want to be able to try to write a y equals mx plus b, where m is the slope. So I want to pick 2 points from my line of best fit to try to get a slope that's going to model this. And my b, which is my y-intercept. Now obviously if we spend 0 hours in the mall, we're going to spend $0. For this situation, my y-intercept would be a 0. And my slope is going to depend on the 2 points that I use from my line of best fit. I took the one that they were on the extremes, the farthest one out and then the one closest in, but still I chose 2 that were on my line. So the slope is going to be the change in the y's, 54 minus 36. And if you've forgotten how to find slope, there are some videos way back early on calculating slope that you may want to check out. And 7 minus 5, that's going to be 2. 54 minus 36. Let's see, 54 minus 34 is 20, and I actually subtracted 36, so it should be 18. Gives me a slope of 9. So y equals 18 divided by 2 gives me a slope of 9. Y equals 9x. Let's see. If I spent 5 hours in the mall, 5 times 9 is 45. If I spent 7 hours in the mall, 7 times 9 is 63. Remember, it's not a perfect match every single time. I guess I didn't use the farthest one out. But you're trying to get a line that fits as many as possible. 8 hours in the mall times 9, $72. This was an extreme case. It didn't quite fit along. 4 hours in the mall times 9 is 36. This one was a little bit high, but it's kind of close to 36. 3 hours in the mall times 9, you'd spend 27. This one spent pretty close to 27, so that this graph model is a pretty good model of my points. And hopefully that slope is right. It may not be perfect for every single point, but it's a line that fits as many of the data points pretty closely as you can.